Hi guys, I know I've already covered this. It was kind of squeezed into the end of last lesson and I wanted to do it properly. So I know we've already looked at using vertex testing and the objective function method, also called the ruler method. And then right at the end I talked about what would happen if your solutions were an integer. So I thought we'll just have a little bit more time on that today. And then next lesson, I'm just giving you one question out of the next exercise before we start the simplex method. So I've got a question for you here. It's already been solved, so 3.8 and 7.4. However, imagine your question needs integer values, as most things would. So we're looking at the number of, diaries and the number of journals, for example, something that we need whole numbers for. So we've got our solution and we've also worked out the maximum. However, we need integer solutions. Now that point there is clearly vertex B. Either using the objective line method or the vertex method, we've come up with vertex B is the solution. Now what we need to do is have a look at all of the integer solutions just around that point there. And we've got 4 different possibilities. So we're going to test all 4. So we could round 3.8 down, or we could round 3.8 up. We could round 7.4 down, or we could round it up. So we've got 4 different solutions there. And if we were to zoom in on here, we might be able to see a bit more detail around the point. We might be able to tell which of those points actually lies within the feasible region or which ones are in the shaded region. However, I haven't got that information on my graph. It's highly unlikely you would in the exam. So we have to test those 4 points. So what I'm going to do is put each of those coordinates into the inequalities that make up that graph. So all 3 of these inequalities, I know the equations on the graph, they're inequalities over here. I've written them down into a table and I've got the 4 different possibilities here. This is a slightly different table to the one I used last lesson because I've got more space. So I've actually written in what the inequalities are. If I put 3, 7 into the first one, I get 14 take away 3, that equals 11, so that one works. If I do it for 3, 8, I get 16 take away 3 equals 13, that one doesn't work. Next one, 14 take away 4 equals 10, does work. Last one, 16 take away 4 equals 12, that one doesn't work. So already we are down to 2 solutions here. It's either this one here or this one here. So I don't need to check the other 2. So I move on to the second inequality. If I substitute 3, 7 in, I get 3 plus 21 equals 24. So that one works. If I do it for 4, 7, 4 plus 21 equals 25. That one also works. I move on to the third inequality. I get 6 take away 7. Well, I know it's negative, but it still works. And 8 take away 7. Yes, that one works too. So actually either of these 2 work. So what I have to do now, this is the graph zoomed in a little bit. So you can actually see now that these 2 options are in the feasible region. It wasn't clear to see that before. So we've done the right thing here. We've investigated each point. We've got down to 2. Now, Back here, we want to maximise. So what we're going to do is substitute both options into the objective function. And because we want to maximise, let's just choose the maximum. So we've got two options, 3, 7 and 4, 7. If I plug in 3, 7, I get V as 55. If I plug in 4, 7, I get 57. So my optimal solution is 4, 7, and that gives a maximum of £57 or whatever it happens to be. I hope that helps a little bit more, because I did feel like my last explanation was a bit rushed, and I don't think I'd looked at an example where there were two possible solutions and you actually have to choose which one is the best. Obviously, if we were minimising, we would have gone for 3, 7. Can you please try from exercise 6D? There's 4 questions. Unfortunately for these 3, you are going to have to draw a graph and try and make it as big as possible. And then for, I think it's Tuesday's lesson, for the second lesson on Tuesday, I want you just to have a go at question 4 from the mixed exercise. And then what we'll do from Wednesday is start the next chapter along, which is the simplex method. Bye for now.